Hello everybody, and welcome back to another video on my channel. Today we will be talking about inclined planes, which is an extremely important concept in dynamics and physics, and even though it might seem simple, its implications are extremely large and are foundational throughout all of mechanics. So without further ado, let's move on to the video. An inclined plane is pretty simple when you look at it. It's basically, you have one line here, and one line here, and that makes a triangle. Now this triangle has an angle of theta degrees with the horizontal. So what does this actually do? Well, its real magic comes when we put a block on it. So there's a block over there. Let's say this block has a mass of m. Now its weight, which is gravity, is downwards, which is mass times gravitational acceleration. But as you can see, this plane is on an incline. So the question is, how can we predict motion when our plane is not in the same direction as gravity? The answer to that lies in splitting gravity up into two components. One component, which is perpendicular to the plane and is going inwards, so like this. This is mass times gravitational acceleration, so the weight of the object, times cosine of theta. And one direction parallel to the plane, which is mg sine theta. So that is the answer to our question and the basis for all things involving inclined planes. Basically, we're splitting up gravity and all other forces in either the horizontal or vertical direction into a component perpendicular to the plane and a component parallel to the plane. So I think that's really about it for our explanation, and we will get more and more knowledge when we come to use these concepts in problems in accordance with Newton's laws and kinematics. So let's get started on our first problem. Over here, we have our first problem. Now, if we just look at it head on, this is a lot of words and it might seem incredibly confusing. But let's break this down step by step. So first of all, there's an inclined plane with an angle of 30 degrees with the horizontal. The mass of an object on this inclined plane is 3 kilograms. So that's that. Friction is non-existent in the scenario, and assume g is equal to 10 meters per second squared. This will be constant for all of our problems, so I will not be writing those two sentences for the next 3 or 4 problems. And what next is find the force required to balance the object where the direction of this force is parallel to the incline. Now, right now, feel free to pause the video if you know this and solve the problem so you'll get your practice in and you'll also get better at the concept and possibly develop a greater interest for it. But if you don't know how to solve it, which I'm assuming is a decent chunk of you, stay along and let's walk through it together. So over here, I have a few things highlighted. So first, we have an inclined plane. So we already know we're going to be talking about what I talked about earlier in the video. So let's have this inclined plane of angle theta, which is equal to 30 degrees. Now the mass of an object on this inclined plane is 3 kilograms. And friction is non-existent. Assume g is equal to 10 meters per second squared. And the last part is find the force required to balance the object where the direction of that force is parallel to the incline. So, as we saw earlier, the force mg sine theta is the force that is trying to put this towards the ground and is making it slide down the plane. Now we want a force that is equal in magnitude and opposite in direction to this mg sine theta, so it neither moves up or down. So that means the net force is equal to 0. Okay, so now that we have that done, F net is equal to 0, that's one thing. And now that we know exactly what our force is, let's start plugging in the values and figuring it out. So if the net force is equal to 0, then our force minus mg sine of theta is equal to 0. So our force is equal to mg sine theta. Now, let's plug in our values. Our force is equal to 3 times 10 times sine of 30 degrees, which is equal to 30 times 1 by 2, which becomes, after simplifying, 50 newtons. And this is the answer to our problem. So, this just shows a very basic application of this inclined plane, and it shows very simple how one can do what they do. So, that's pretty much about it for this problem, and let's move on to our second problem. Over here, we have our second problem. This problem states there is a block with a mass of 1 kilogram on an inclined plane with an angle of 30 degrees. The length, hypotenuse of this inclined plane is 10 meters, and the object starts from the top of this inclined plane, and this object also starts at rest. Find out the time it takes to get to the bottom of the plane. Now, if you know this problem or you want to try solve it on your own, feel free to pause the video, just like I said in my last problem, and work it out on your own. But if you want to see me walk through this problem with you, feel free to continue watching. So, for those who have stuck around and are continuing to watch me, here we go. Problem. This says that there is a block with a mass of 1 kilogram, and then our incline is 30 degrees. The length is 10 meters, and we start from the top of this inclined plane and at rest. And what are we trying to find? We are trying to find the time. So, what we can do is first, let's draw our inclined plane. This is 10 meters. 10 meters. This angle is 30 degrees. Then, after that, our block over here is starting at the top. This block has a mass of 1 kilogram. Now, of course, I said it's frictionless and gravity is 10 meters per second squared in my last question, and I said it's assumed for the rest of the questions. So, there goes that, and this is really all we need to solve the problem. So, let's go. So, there are multiple equations from the Big Five or kinematics that we can use to find time, as the only way we know how to find time as of now is through kinematics. So we have two problems. We have the distance is equal to v0 plus 1/2 of a times time squared, or we have vf is equal to v0 plus the acceleration times the time. Now there's also velocity is equal to distance times time, but these are very important right now for reasons that I'm going to show you in a bit. So that formula is automatically crossed out. And also the reason I crossed out that formula is because it has velocity, or really final velocity. And final velocity is very annoying to deal with. So let's also cross this out. So the only formula left, and it turns out the best formula, is x is equal to v0 plus 1/2 of at squared. So this is our formula that we are going to use. So if we plug in the numbers, then what we already have, so our distance is 10, so we have 10 is equal to 0 plus 1/2 times our acceleration times time squared. Now, let's find out this acceleration. Now, our acceleration is the acceleration that is parallel to this incline down the ramp. Now, we know from earlier that our force is equal to mg sine theta, but our acceleration is equal to force divided by mass because of Newton's second law, which I already said earlier that we are going to be using Newton's laws and other stuff in this. So if you just realized, make sure you go back to those videos on my channel and make sure you watch those. But now that we know that F is equal to ma, we know that mg sine of theta is equal to mass times our acceleration, and our acceleration, when we divide by m, is equal to g sine theta. So now that we know our acceleration, let's evaluate. So we have 10 is equal to 1/2 times g, which is 10, times sine of 30 degrees times squared. So 10 and 10 cancel out. Sine of 30 is 1/2. So 1/2 times 1/2 is equal to 1/4. And multiplying by 4 on both sides gives us t squared is equal to 4. And as a result, the time is equal to 2 seconds. So the time it takes to travel to the bottom of this plane is equal to 2 seconds. Our third problem looks very similar to the first problem, but has one key difference. This problem reads an object of mass 7 kilograms is on an inclined plane with an angle of 60 degrees. Find the force required to balance the object and keep it from falling. The direction of this force is purely horizontal. Now this creates entirely new implications on how we have to solve this and adds one extra step that most people might not realize. So, as of always, if you know how to solve this and you want to practice, please feel free to pause the video and practice this problem. But otherwise, I would highly recommend watching through with me, as this is slightly different and you might not understand it at first. So, let's first get our basic setup. We have an inclined plane of an angle of 60 degrees. And now we have some mass with an object mass of 7 kilograms. But instead of having our force be parallel to this inclined plane, we have it be purely horizontal. So if this is our force, this would be our mg sine theta, and our perpendicular would be our mg cosine theta. Now, let's look at this force F first. So now this force F is purely in the horizontal direction, but if I draw a line over here, and this angle is 60 degrees, and then I draw a vertical line, so this is a 30, 60, 90 right triangle, this side becomes F divided by cosine theta, because this side, the hypotenuse, times the cosine of the angle, which is 60, is equal to the horizontal, which is F. So now we know this is F divided by cosine theta. And since that's in the same direction as our mg sine theta, since our net forces has to be equal to 0, we're going to have F divided by cosine theta is equal to mg sine of theta. Then what we have is F is equal to mg sine theta times cosine theta. Now we have our angle 60 degrees and our mass and our given gravitational acceleration. So we can plug in the values and solve for F. So F is equal to 7 times 10 times sine of 60 degrees is the square root of 3/2 times the cosine of 60 degrees is equal to 1/2. So now that we have that, what we can do is we have 7 times 10 times square root of 3/2 times 1/2 is 70 times the square root of 3/2 times 1/2. Now this becomes, if I drag this all the way over here, this becomes, if I have 70 and 2, 35√3, and then 35√3 divided by 2. So F is equal to 35 times the square root of 3 divided by 2 newtons. Because what happens is since we have F divided by cosine theta is equal to the hypotenuse, because cosine theta is always less than 1 or equal to 1, and the hypotenuse is always greater than the edge length. So it makes sense why it would be F divided by cosine theta as it's an adjacent. So what we have, and this is equal to mg sine theta, and plugging it all in gives us a force of 35 root 3 divided by 2 newtons, and this is our answer. Basically, this problem revolved around realizing that the force that would balance it in the same direction has magnitude F of cosine theta, but our actual force would change depending on the angle that it is given at. So that's our third problem, and let's move on to our fourth and final problem. This is our fourth and final problem for today. This problem states an object is on some inclined plane with an angle of theta. This for the force of gravity perpendicular to the plane is 100 times the square root of 2 newtons. The force of gravity parallel to the plane is also 100 times the square root of 2 newtons. Find theta and the mass of the object. So, what we have over here is if the force of gravity perpendicular to this plane is 100 times the square root of 2 newtons, that means mg times cosine theta is equal to 100 times the square root of 2. Now, the force parallel to the plane is mg sine theta. So if this is also equal to 100 times the square root of 2 newtons, what is our angle theta and our mass? So one thing you can do is when you're given forces parallel perpendicular, or you have pretty nice equations with sine theta and cosine theta, and you to find theta, is you should have the equation with sine theta, divide that by the equation with cosine theta. So mg sine theta divided by mg cosine theta is equal to 100 times the square root of 2 divided by 100 times the square root of 2. Now mg gets cancelled out, 100 square root of 2 cancels out, and sine theta divided by cosine theta is equal to tangent of theta. So tangent of theta is equal to 1. That means theta is equal to the tangent inverse of 1. And by knowing our identities, we know that theta is equal to 45 degrees. So now we have one of our two answers. Our next answer revolves around finding the mass. Now, let's plug theta is equal to 45 degrees in any one of these equations. Let's do mg sine theta. So, if mg sine theta is equal to 100 times the square root of 2, that means m times 10, which is g, times the square root of 2 divided by 2, which is sine of 45, is equal to 100 times the square root of 2. Now, square root of 2 times square root of 2 cancels out. Dividing by 10 on both sides gets us 10, and then multiplying by 2 gets us 20. So our mass is equal to 20 kilograms, and that is the answer, the second answer to this problem. Now, the reason I would have this type of problem is because especially when you're deriving formulas or working with anything related to friction, you're going to have to divide mg sine theta by mg cosine theta and use some form of the inverse tangent of theta. So, this is a very good introduction to that type of problem, and I will be covering more about that in the future. So, for now, thank you so much for watching this video. If you enjoyed it enough to like and subscribe, please do. Also, turn on those notification buttons for more awesome videos like this. And please make sure to comment down below in order to help my channel improve. So please comment any suggestions, comments, or just encouragement so I can improve this channel and make this a better place and a better channel for all of you so you can learn better and reach your maximum potential in physics. Thank you so much for watching. See you in the next one, and bye-bye.